Howdy, people. Today we're doing 9.4. It's about polygons in the coordinate plane. So this is the last section of chapter 9. We're actually skipping 9.3 just for time's sake, but yeah. 9.4. Okay, so it says you and your friend are playing a board game. Players place rubber bands on their square grid to form different shapes. The object of the game is to guess the vertices of your opponent's shape. How would you place the pieces on the grid shown to complete a right isosceles triangle? Okay, so a right triangle, makes a right angle. An isosceles triangle, well, that means it has two sides that are congruent. They're equal in length. So if we need to make a right isosceles triangle, well, to make a right triangle, we could do something like this. But the problem with that is it's not isosceles, so we can't do that. So we need to make something that's the same length as this, and also perpendicular to that. So if you remember, perpendicular lines have opposite slopes. So if I look at this point, to go from here to the point up here, I need to rise 3 and run 1. So I'm going to do the opposite of that. From that point, I'm going to go rise 1, and then run, or I'm going to go, rise 1, run 3. Actually, that's going to be off the board, so I can't do that. So actually, let's go down 1 and over 3. 1, 2, 3. So I went down 1, over 3. Oops. Okay, so if I connected those points with another rubber band, that should make a right angle. And I know that those are going to be the same length. Okay, so that's one possible vertex. Is that right? 1, 2, rise, 1, 2, 3, run 1. Run 3, down 1. Yeah, that should be right. So that's one possible vertex. What if we went from here? We went, so to get from that point, you go down 3, back 1. So we could go over 3. 1, 2, 3, down 1. So you could also do it right here. That's another possible vertex. So either of those two would make a perpendicular line, and hence a right isosceles triangle. Okay, so we've talked about these three formulas. We can use these to show that two figures are, for example, in the last one I showed that a triangle was isosceles by showing the distance was the same and then it formed a right angle. So we have distance formula. These are all important. You should have these written down somewhere. Use the distance formula to determine whether sides are congruent or diagonals are congruent. So basically to determine congruence. The midpoint you can use to determine the coordinates of the midpoint, or if the diagonals bisect each other, meaning that they cut each other in half. And the slope formula is useful because you can determine if sides are parallel or perpendicular. If they're parallel, they have the same slope. If they're perpendicular, they have opposite reciprocal slopes. Okay, and then this says show that triangle ABC is isosceles. So to do that, we need to show that two of the sides are the same. So in this case, because we want to show that two sides are congruent, we use the distance formula. So let me rewrite it. Distance equals square root, parentheses, x2 minus x1 squared plus y2 minus y1 squared. And then we just plug in our points. So if I want to find, if I look at these, it looks like this side and this side is probably the ones that are congruent. So I'm going to do A and B first. So my coordinates for A are 0, 1. B is 4, 4. So I need to plug those into the distance formula first. So my two x's are these two, 0 and 4. So I should get AB square root 4 minus 0 squared plus my two y's are these two. So y minus y, 4 minus 1 squared. And that comes out to be square root 4 minus 0 is 4, 4 squared is 16, plus 4 minus 1 is 3, 3 squared is 9. That's 25, which comes out to be 5. So this side right here is 5. Now we just need to show that the other side is also 5. So if I go from B to C now, C is at 7, 0. So now I just need to plug in B and C instead of A and B. Okay, so we have BC, square root, my two x's are 7 and 4, so 7 minus 4 squared plus 0 minus 4 squared. 7 minus 4 is 3, 3 squared is 9. 0 minus 4 is negative 4. Negative 4 squared is positive 16. So again, you get 16 plus 9, which is square root of 25, which is 5. Okay, so this side is also 5. So now we know that triangle ABC is isosceles, because two of the sides are the same. Okay, if the third side was the same, it would be equilateral, because all three sides would be the same. Okay, this one it wants you to show that the triangle is scalene. Okay, scalene means all three sides are not the same, so none of the sides are the same. So you can use a distance formula to show that, so I'm going to let you try that. So find the distance between each of those points, and I will do it myself. So pause this in 3, 2, 1, pause. Okay, so I didn't graph it, because you really don't need to here, but the distance between D and E, I plugged them all in, and I got square root of 17. DF is square root of 29, this is 29, and then EF is square root of 20. I could have simplified those down into decimals, but it is not necessary because the square roots are all different. So I know that all the sides are different, and it is a scalene triangle. Okay. Show that QRST is a parallelogram. So if we're going to show this as a parallelogram, we need to show that both pairs of opposite sides are congruent, or not congruent, they are parallel. So I need to show that this side is parallel to this side, and this side right here is parallel to this side right here. So to show two lines are parallel, what we do is we just show that the slopes are the same between the 2 points. So the slope of QR, so my slope of this line right here, so I'm just going to do it like this, slope of QR. So I rise 2 to get from Q to R. Rise 2, run 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Rise 2, run 5. So 2 over 5. And then I can do my slope of TS. So my slope M of TS, we'll do it like that. I rise 2, run 1, 2, 3, 4, 5. Okay, so those are the same. So then we know that QR is parallel, that's the symbol for parallel, to TS. Okay, so that tells us one pair of opposite sides are parallel. Now I need to show that the other side is also parallel. So now I can do from Q to T like this. So the slope of QT is, I need to rise, so I need to go down 1, 2, 3, 4, 4. Go down 4. Oops. So negative 4, run 1. So down 4 over 1, which is just negative 4. Then I need to do the same thing from R to S. So the slope of RS, I go down 1, 2, 3, 4 over 1. So negative 4 over 1, which is negative 4. So that tells us that QT is parallel to, oops, not Q, RS. Okay, if the slopes are the same, that means our lines are parallel. All right. Okay, so I've graphed this rectangle here. It says parallelogram MNPQ has these vertices. Show that it is a rectangle. So we already know it's a parallelogram, which means that we know this side is parallel to that side, and these two sides are also parallel. So to show that it's a rectangle, all I have left to show is that these form right angles here. So to show that two lines form a right angle, I have to show that they are perpendicular, meaning their slopes are opposite reciprocals. So opposite reciprocal means the fraction is flipped, and if it's negative, it becomes positive. If it's positive, it becomes negative. So to do that, let's look at NP first, this top line right up here. Okay, so the slope, we're looking at the slope of NP. I'm going to rise 1 run 1, 2, 3. So 1/3 is your slope. So we want that to be opposite to the slope of MN. So the slope of NM. So the slope of NM, we're going to go down 1, 2, 3, and over 1. So -3, because I went down 3, over 1, which is just -3. Okay, those two are opposite reciprocals because if you look at those right there, the fraction's flipped, and one is positive, one is negative. So I know now that this is a right angle. Okay, and if I prove, or if I show that this is also a right angle here, then I can say this is a rectangle. So now, actually no, I think that's all we need to do really, because we know that these two lines are already parallel. Let me see, change colors. I know this line is parallel to this line, and I know this line is parallel to that line. So because they're parallel to each other, that means they're going to be perpendicular to the same lines. And we know it's parallelogram, so if we can prove that one angle is a right angle, then we know that the other three are also right angles. So that's how we can show that it's a rectangle. Just show that the slopes are opposite reciprocals. Okay, so we can say that NP is perpendicular, so this is the symbol for perpendicular, to NM. Okay, and then all the rest of them are also perpendicular. So it's a right, there are right angles and it's a rectangle. Okay, last one here. So we have a kite. It says show the quadrilateral formed by connecting the midpoints of the sides is a rectangle. Okay. So we need to find the midpoints of all the sides first. So if I list my points, actually I have them listed here. The midpoint of KI, this side up here, I'm going to look at K and I and I'm going to find the midpoint of KI, midpoint of KI. So I'm going to do the average of the x's. So -4 and 0, so -4 plus 0 divided by 2. And then, so that was the x's here and here. Then I'm going to do the average of the y's, 0 plus 4 divided by 2. So that just gives us -2, comma 2. So that's the midpoint of the segment KI. So that's that one right there. Okay, then we need to do IT, the midpoint of IT. And I is 0, 4, T is 8, 0. So we're looking at these two now. The x values are 0 and 8, so 0 plus 8 divided by 2. Y values are 4 and 0.
Hey, Jonathan.
Okay, then we got to look for the average of the y's. So our y's are 4 and 0. So 0 plus 4 again, divided by 2. So same as the last one. So we get 8 divided by 2 is 4. 4 divided by 2 is 2. So 4, 2 is going to be the next one. So over 4 up 2 right here. You can probably just figure these out pretty easily on here as well. But we might as well use the formula since we have it. Okay, then let's do TE. So now looking at these two. So we have 8 and 0 again for your x's, and then 0 and -4 for the y's. So I'm just adding them together and then dividing by 2 to get the midpoint. 8 plus 0 is 8, divided by 2 is 4. 0 minus 4 is -4, divided by 2 is -2. So 4 -2 is this one right here. Okay, and then the last one, I'm going to erase this so I have room. And the last one we need to do KE. So now we're looking at K and E. So average of the x's, so our x's are -4 and 0, so -4 plus 0 divided by 2, since we're adding two things together. Average of the y's, 0 and -4, so 0 plus -4 divided by 2, so we get -2, -2. So that's that point right here. Come on, hello. Okay, right there. And it says if we connect the midpoints, so connect all these four, they make a rectangle. Okay, So we found the midpoints, and then we can say that indeed it is a rectangle, because these are actually, we don't really need to even use the slope here because we have vertical and horizontal lines, which is quite convenient. So we can say that, I guess we should have called these something. Call them A, B, C, and D. So we can say that AB is perpendicular to BC, and that is BC is perpendicular to CD, since we have a vertical and a horizontal line, and CD is perpendicular to AD, and AD is perpendicular to AB, like that. Okay, so hence we have a rectangle.
Attention, junior high teachers. For all boys volleyball players
Right,
that are checking
and
out to go to the game, please
that
check out now and
is
come to the office.
all I have
Thank
for
you.
9.4. So please do the quiz on time, and I will catch you all on the next one. Adios, au revoir, peace out.